Okay, binomial theorem. This is a fun one. Yay. Okay, so before we can dive into binomial theorem, the binomial theorem is just a theorem that helps us expand binomials. And remember, a binomial is something with two terms. And we have to use Pascal's triangle to do this. So Pascal's triangle is a pattern of numbers that was discovered in the 13th century, so way long ago. And each number in Pascal's triangle is the sum of the two numbers diagonally above it. And the outside numbers are always 1. So we need to complete rows 4 and 5, but I want to watch this cute little YouTube thing real fast, hopefully. Whoa, neat. Okay, stop. How do I get out of this? All right, struggling, sorry. So that's just a little brief introduction to Pascal's triangle. And there's lots and lots of patterns in this. If you want to learn more about it because you're a math nerd, then just Google Pascal's triangle. There's lots of cool videos on it. But let's get into this. So the first row, or row 0, we don't call it the first row. We call it row 0. Is just 1. Row 1 is 1 and 1. Row 2 is 1, 2, and 1, because 1 plus 1 is 2. Row 3 is 1, 3, 3, 1, because, so 1 is always on the outside. 1 plus 2 is 3. 2 plus 1 is 3, and then 1 on the outside. So let's find the next one. So you always start with 1. Now 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then 1. Then the last row is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then 1. Okay, and this keeps going forever. Like, you literally can go forever if you wanted to. You would be absolutely insane if you did that, though. Let's get into expanding this. So let's expand this the way that we know how to. And let's write it out 3 times. So we have a plus b, a plus b, a plus b. Now if we expand that first one, that's a squared plus ab plus ab plus b squared times a plus b. So now we have a squared plus 2ab plus b squared times a plus b. Sorry if I repeated that. An announcement came on. I got distracted. Now we're going to multiply the a plus b in. So that's going to be a cubed plus a squared b plus 2a squared b plus 2ab squared plus ab squared plus b cubed. Combine like terms and you get a cubed plus 3a squared b plus 3ab squared plus b cubed. Whoa. But if we look at the third row of the Pascal's triangle, our coefficients are the same. So we have, this is the third row right there. So 1, 3, 3, 1. Maybe I should have wrote 3 right there. 1, 3, 3, 1. Okay. Now I'm going to teach you a way to do this where it's a little bit more organized and we're not doing so much distributing and just a lot of kind of messy algebra. Okay. And it's not too bad when there's 3, but we have 5, we have 7. You can get up to however big I'm feeling. If I'm feeling mean, I could give you like a 20. I probably won't do that. I'm not very mean. But let's see. So we have a plus b to the 5th power. Now, first we're going to look at the power. This is raised to the 5th power. And we're going to use this to determine how many boxes to draw. It's always one more than the power given. So we're going to draw 6 boxes because it's raised to the 5th power, so we're going to draw 6 boxes. 1, 2, 3, 4, 5, 6. Okay, and I want you to do this on your paper. Draw the 6 boxes. Now let's look at Pascal's triangle. And I'm going to go to the 5th row. Now the fifth row is the row with 5 as the second number. That's the easiest way to remember the rows. Like the fourth row is 4 as the second number. The eighth row is 8 as the second number. The fifth row is 5 as the second number. And I'm going to put those numbers in my boxes. So I have 1, 5, 10, 10, 5, 1. And that's all that's going to go in those boxes for now. Then I'm going to draw a second row of boxes right underneath them. And the first term is going to go in those boxes. So A is going to go in all those boxes. And I'm just going to put them in parentheses. I want you to do that too because I want you to get in the habit of it. Just in case we had like a 2A or something. Because if you square that, you have to square both terms. Okay? Now, we have to work with our exponents. The exponents start at 5 and count down. They start at whatever number this is right there. So since that's a 5, that's why we're starting at 5. So that's going to be a to the 5th, a to the 4th, a cubed, a squared, a to the 1st, a to the 0 power. Then we're going to draw another row of boxes. And in these boxes, we're going to put our b's. And for these ones, the exponents start at 0 and they count up. So that's going to be b to the 0 power, b to the 1st, b squared, b cubed, b 4th, b to the 5th. Now, anything raised to the 0 power is 1. So we can cancel those boxes out. So I'm going to cancel that box out, cancel that box out. And you will always have boxes that cancel out when you're doing this. Now we're going to draw one more column, and we're going to simplify each box. So in that first column, I have 1 times a to the 5th. The second one, I have 5 times a to the 4th times b. The third, I have 10 times a cubed times b cubed, or b squared, sorry. Then I have 10 times a squared times b cubed. 5 times a times b to the 4th. And then 1 times b to the 5th. I'll draw another box. Sorry, I lied. We are drawing more boxes. 1 times a to the 5th is a to the 5th. 5, a to the 4th, b. 10a cubed, b squared. 10a squared, b cubed. 5ab to the 4th. And then b to the 5th. Then we put plus signs in between each of these. So wherever the box ends, there's a plus sign. And our final answer is a to the 5th plus 5a to the 4th, b. Plus 10a cubed b squared, plus 10a squared b cubed, plus 5ab to the 4th, plus b to the 5th. Cool? Let's do another. So this time, this is to the 7th power, so we're going to have 8 boxes. I'm going to look at the 7th row, and that's what's going to go in that first row of boxes. Draw the second row, put my x's in there. And I start at the 7th power because that's what my original binomial was raised to. So that's going to be x to the 7th, x to the 6th, x to the 5th, 4th, 3rd, 2nd, 1st, 0. Draw another row, and this is going to be my y's. You start at 0 and go up, so that's y to the 0, 1, 2, 3, 4, 5, 6, 7. Those cancel because they're raised to the 0 power. Then I have 1 times x to the 7th is x to the 7th. 7 times x to the 6th times y to the 1st is 7x to the 6th y. 21 x to the 5th y squared. 35x to the 4th y cubed. 35x cubed y to the 4th. 21x squared y to the 5th. 7x y to the 6th y to the 7th. Put plus signs between each of those. And you get x to the 7th plus 7x to the 6th y plus 21x to the 5th y squared plus 35x to the 4th y cubed plus 35x cubed y to the 4th plus 21x squared y to the 5th plus 7x y to the 6th plus y to the 7th. Booyah. Okay, so in a binomial expansion, the total number of terms is always n plus 1. So if it's a plus b to the 3rd power, we're going to have 4 terms. If it's to the 5th power, we're going to have 6 terms. If it's to the 100th power, we're going to have 101 terms. So it's always n plus 1. The exponent of a in the first term is n. The exponent of b in the last term is n. And the exponent of a decreases from left to right because you start high and low. The exponent of b increases from left to right. The sum of the exponents in each term is n, and the coefficients are multiplied and follow the nth row of Pascal's triangle. Okay? So let's do this one. We've already filled out this box for you, or I have filled out this box for you. So it's to the fourth row, or fourth power, so I use the fourth row of Pascal's triangle. I put 2x in that first box, so I have 2x to the fourth, 2x cubed, 2x squared, 2x to the first. Then I have 5 in the third row, so 5 to the first, 5 squared, 5 cubed, 5 to the fourth. These ones right here, this would have been 2x to the 0 power, so that's why it's gone. This one would have been 5 to the 0 power, so that's why that one's gone. Okay? Now, let's start to simplify this. So 2x to the fourth power, you have to do 2 to the fourth power, which is 16, and then x to the fourth power, which is x to the fourth. Next one, we have 8x cubed, 8x cubed. 2x cubed is 2 times 2 times 2 is 8. X cubed. 5 to the first power is 5. Then 6, 2x squared is 4x squared. 5 squared is 25. 2x to the first power is 2x. 5 cubed is 125. And then 5 to the fourth power is 625. So we can multiply these out. So that's 16x to the fourth. 4 times 8 times 5 is 160x cubed. 6 times 4 times 25 is 600x squared. 4 times 2 times 125 is 1000x. And then 625. Add our plus signs, and you get 16x to the fourth plus 160x cubed plus 600x squared plus 1000x plus 625. Cool? Let's do this one right here. So we have 2x minus 3 to the fifth power. It's raised to the fifth power, so I'm going to draw 6 boxes. Look at Pascal's triangle. Go to the fifth row. 1, 5, 10, 10, 5, 1. Draw our second row. 2x goes in there. Now this is raised to the fifth power, so I'm going to start with 5. So 2x to the fifth, to the fourth, 3, 2, 1, 0. And then negative 3 goes in the next row. And you have to keep that sign with it. We haven't dealt with negatives yet, but now we are. So since that's a minus 3, we have to keep that negative 3 with it. Start at 0 and count up. So 0, 1, 2, 3, 4, 5. Anything to the 0 power cancels out. And then let's just start simplifying this. So 2 to the fifth power is 32, x to the fifth. 5, 2 to the fourth power is 16, x to the fourth. Negative 3 to the first power is negative 3. 10, 2 to the third power is 8. X cubed, negative 3 squared is 9. Then 10 times 4x squared, negative 3 cubed is negative 27. 5 times 2x and negative 3 to the fourth is 81. And then negative 3 to the fifth is negative 243. We can multiply those out, so you get 32x to the fifth. 5 times 16 times negative 3 is negative 240, x to the fourth. 10 times 8 times 9 is 720, x cubed. 10 times 4 times negative 27 is negative 1080, x squared. 5 times 2 times 81 is 810x, and then negative 243. Add our plus signs. So you get 32x to the fifth plus negative 240x to the fourth plus 720x cubed plus negative 1080x squared plus 810x plus negative 243. And if you add a negative, that's the same as subtracting, so we can just rewrite it like that. Okay, I would accept either answer here. This is the more correct answer, the bottom one, but if you put this, we're still okay. Okay? Thanks for watching. Remember to take the quiz. You guys rock.